Hello friends, today we are going to start with the next module, that is transducers. So in this module we are going to understand and trying to learn the things related to the transducers, such as the classification of the transducer and its characteristics. Then there are different types of the transducer there on the basis of the its changes happening in the physical quantities and other things. Also, now we'll try to understand the displacement transducer, then force transducer, temperature measurements, and at the end, maybe we'll try to understand the temperature measurement techniques. And in that one, we'll be looking into the non-electric as well as the electrical methods of the temperature measurement techniques. So let's see, the in the introductory part, what we understand from the transducer is nothing but the is a kind of the device which converts the one form of the energy into the other kind of the energy. Okay, so for that case, what we need is a kind of the primary sensor. And what is the sensor? Sensor is a device which is used to detect the changes in the physical quantities. And which are the physical quantities are they? The temperature, and then the speed of flow, then the level, pressure, etc. So these kind of the physical changes are detected by the sensors, and these changes in the input quantity will be detected by the sensors and reflected as changes in the output quantity. So the output of the sensors will be some other form of the energy. So the input, which are the quantities are at the input, such as the speed, flow, then the level or the height, the pressure, temperature, the actuator. There are various devices which are present in the transducer. The one of them is the actuator, and is a device that responds to the signal with a physical movement, and can be considered as a transducer one. So the actuator is a type of the, we can consider as a transducer one, okay, which is acting as a transducer here. So, for example, that is the microphone is a sensor which converts the sound waves into the electrical signals, and a loudspeaker is an actuator which converts the electrical signal back into the audio signal. And there is one more example, that okay, the way in which I am just now trying to record the video, so the my sound energy is converted back into the uh, electrical signal, and the electrical signal will be stored in the device, and again it can be converted back into the audio signal by the at your end as well. So this is one of the example of the transducer as well. In general, a transducer is a device which converts the one form of the energy into the another, or same by the principle of the transduction. In this module, we will be trying to study, as I said it in the earlier as well, the classification and the character of the transducer and its various types. In this, we'll be trying to see its principle, working principle, construction, application, advantages, disadvantages. Now let's see the classification of the transducers. The transducer device that converts the primary form of energy into the corresponding signal with a different or the same energy form. Uh, Primary energy forms are such as the mechanical, or the thermal, or electromagnetic, chemical, etc. So these are the energy forms in which the sensors detect the changes happening in the physical quantity. Which are they? The mechanical, thermal, electromagnetic, chemical, etc. The transducers converts these energies into the measurable form, which is depends upon our requirement, in which form we required its energy form. Example are the mic, speaker, photodiode, solar energy. Right, so mic detects the sound energy. Speaker converts the electrical signal back into the sound. The photodiodes detects the light energy and converts again into electrical energy, and then back again to the we can say okay, so the photodiode converts that photo energy to electrical signal, then the solar cells which converts the solar energy into the electrical signals, and so on and so forth. So the schematic representation of the transducer system is this. So the primary changes or the signal will be uh, detected by this microphone. Okay, this is the input device. Then this will be microphone which convert that sound energy is converted into the electrical signal. Electric signal, its mm, uh, value or the signal strength is very low, so we need to amplify that signal, so we can have the intermediate state is the controller. Here the amplification of that input signal can be done, and this amplification is conversion of the one form into the similar form, but the its strength of the signal will be the increased by this amplification uh, phenomena. Then this output of the amplifier is given to the output device, and which can actually drive the output signal, because amplification is required so that the weak signal of the microphone does not drive the loudspeaker. So intermediate stage or the controller is required to amplify the signal, so that the input signal can drive the output loudspeaker, and the again that electrical signal will be converted back into the sound energy. Uh, Classification of the transducers is based on the different ways. So the few of the ways we are considering over here. The first one is the physical effect. On the basis we can classify the transducers. Then the physical quantity, and the third one is the source of the energy. So on this basis we can classify the transducers, that is physical effect, physical quantity, and the source of energy used. Now first case we will try to understand this nothing but the physical effect. This type of the classification of the transducer is based on the physical effects engaged to convert the physical quantity to the electrical quantity. So the physical quantity will be converted into the electric, and in most of the transducer the physical effects or the physical quantity is changing, is converted into the electrical signal only. uh, Most of the case, not the every case. This change in the resistance of the copper element in proportion to the changes in the temperature. Then another consider here the physical effects which are generally used as the variation in the resistance, variation in the inductance, and variation in the capacitance. So these are the physical effects. Even we can have the Hall effect and the piezoelectric effect as well. Here these physical effects can be detected at the primary stage. Now broad classification of this transducer are like this way. So they are classified into the five different types. The first one is on the basis of the transduction. On the basis of the transduction we are having the different types, that is resistive, inductive, and the capacitive one. The next one is the primary and the secondary transducer. Third one is the active and the passive transducers. We'll be trying to look into details about this all these transducers as well. Analog and the digital transducer, and the last one is the transducer and the inverse transducer. So inverse means the back, we can just convert the action of the energy into its original form. The second one is the physical quantity. On the basis of the physical quantity, how we can classify them transducer. This type of the classification of the transducer is based on the physical quantity converted, that is end use of the transducer alter the conversion. Example here, the pressure transducer converts the pressure into the electrical signal. Then the another effect or the another physical quantities are the temperature transducer. Example is a thermocouple. The pressure transducer, Bourdon gauge. The displacement transducer, LVDT, that is linear variable differential transducer. Then level transducer, torque tube. The flow transducer, flow meter. Force transducer, dynamometer. dynamometer, then acceleration transducer, accelerometer. So these are the types on the basis of the physical quantity. And then the last one is the source of the energy. So this type of the transduce classification of transducer is based on the source of the energy is used. There are two types of the transducer on the basis of this source of the energy use: the active transducer and the passive transducer. The first case we'll look into is the active transducer. So in this transducer, the energy from the input is used as a control signal in the process of the transferring energy from the power supply to the proportional output. What is the case here? In case of the active transducer, we require the some source, auxiliary source of the energy, so that it can drive the input to the output in proportion. Okay, in the proportion. So the here the energy from the input is used as a control signal in the process of the transferring energy from the power supply to the proportional output. Now power supply, uh, okay, then we'll be having the power supply. So how it is just constructed: power supply, then the uh, measured medium, then output of the measured medium is given to the input, then the active transducer required this auxiliary power supply, and then the output of the active transducer is given to the next stage. This is how the source of energy is used in case of the active transducer. This is the schematic representation. The strain gauge is an active transducer in which the strain is converted into the resistance one. Uh, the energy from the strain is very small, and the energy of the output is provided by the external power supply. So energy of the output is provided by the external power supply. We need to drive that input by using the external power supply. Then the another type is the passive transducer. In this case, the energy from the input is directly converted into the output. So in this case, we don't require the auxiliary source, or external power supply is required. For example, thermocouple is a passive transducer. Here the absorbed heat energy is converted into the its electrical signal. So the schematic representation is shown over here. The measured medium, then it is given to the input and then the transducer, passive transducer will be there, and then the output of this passive transducer is given to the next stage. So here there is a no external power supply is used in case of the passive transducer. Now the another type is the analog and the digital transducer. They are classified by their output signals. So the output signal may be continuous or discrete. So the analog transducer uh, changes the input quantity into the continuous function. So here in case of the analog one, we will be having the continuous signal or the continuous function at the output stage. Then the strain gauges, thermocouple, LVDT, thermistor are the examples of the analog transducer. The another type is the digital transducer. Digital transducer converts the an input quantity into the digital signal or the discrete signal it converts. So the input might be changing in the continuous form, but it converts that into the some discrete signal, or it converts it into the digital form, or the discrete signal is discrete signal form. The digital signal works on the low and high powers. Okay, means low signal or the high signal. Okay, we can consider the or 1001 is the binary signal. Mm, uh, Outputs or the inputs can be considered here. The shaft encoders, digital resolver, Hall effect sensors, these are the examples of the digital transducer. Then the transducer and the inverse transducer. So transducer, we know that it converts the one form of the energy into the another one. The inverse transducer does the other way around. Another form can be converted back into the original one. Okay, or else the converting mostly the electrical signal back into the physical quantity is to be measured. So the inverse of the transducer are uh, uh, just the opposite of the transducer's function. So in the inverse transducers converts the electrical signal back into the non-electrical quantity. A current coil moving in a magnetic field is an inverse transducer. Example is the piezoelectric crystal. In a piezoelectric crystal, when we try to apply the force on it, it converts the that signal into the electrical signal, or vice versa. If you just try to apply the potential across it, then it converts that electrical signal into the vibrations of the crystal.